Good morning, students. Today we'll start with the counter programming. So, as we have discussed previously, timers and counters are the topics discussed in module 4. So, the register used for the counter is same as the register used for the timers. The programming, the registers, everything remains same. There is a very slight variation between the timers and counters. The registers used are TH and TL, timer 0, timer 1, TCON and TMOD registers are used. So the counters are used to count the events that are occurring at the outside the 8051. The events that are occurring outside the 8051. So the counter is enabled by the pin C bar, C slash T bar. If C slash T bar pin is 0, then it it is working as a timer. 8051 is working as a timer. If it is 1, it is working as a counter. Rest all remain same, that we are going to load the values. So here the programming used for timer remains same as that for the programming for the counter, except the clock frequency. There we have a crystal frequency of 11.0592. And C slash T bar should be 1 for the operation of counter. And as we have said, the counter will count the pulses that are occurring across the output of the 8051. So the pulses are taken at the pin numbers pin 14 and pin 15. That those are the pins of port 3.4 and 3.5. Functions are T0 and T1, timer 0 or counter 0, external inputs. See, these are the external inputs which are provided for the counter operations to count the events occurring across the 8051. External. And the program we have simple program which is almost similar to that of the timer programming. Here, assuming the clock pulses and are fed to the T1 pin, that is pin number 15, that is 3.4. Write the program for the counter 1. See, there are two counters, counter 0 and counter 1, similar to timer 0 and timer 1. There are again 4 modes, mode 0, 1, 2, 3, 4, which we are going to set in the TMOD register. So counter 1 in mode 2 to count the pulses and display the state of TL1 count on port 2, which are connected to the 8 LEDs. So first we are moving the instructions. TMOD is equals to, this is a value where counter 1 we are taking the first 4 bits, and C slash T bar is 1, so that it is a counter operating, and 1 0 indicates a mode 2, and rest all the bits are 0, which is given in the binary. So it is going to set counter 1 mode 2 C slash T bar is equals to 1, which is used for the external pulses, waiting for the external pulses. Next we are clearing the TH1. Next, set bit 3.5. We are going to make the pin of T1 as input pin. So we are going to make it input means we are going to set it 1, output means we are make it to 0. So it is set bit 3.5. Next, start the counter. That is similar to that. Start TR1, set bit TR1. And next, get the copy of TL register. And remember that mode 2 is an 8-bit timer which counts from 0 to FF. It is an auto reload mode. Mode 2 is auto reload mode. So the value of TL1 is copied to the accumulator and accumulator to the port 2. And we are continuously monitoring the TF1 flag to check whether there is a roll off from FF to 0 by instruction JNB TF1 back. Next, once it is roll off, clear the TR1 means stop the timer or counter, clear the TF1, reset the timer flag, and SJump again. This is a program which is operating in counter 1 mode 2. So Here we have discussed in TMOD register gate pin. If gate pin is 0, we are operating all the timers and counter using the software. Gate pin is 1, we are operating with the hardware inputs. Remember, we are operating with the hardware inputs. So if gate is 1, start and stop of the timer are done externally through the pin numbers 3.2 and 3.3 of the timer 0 and 1 respectively. So this is a hardware that allows to start and stop the timer externally at any time. So here we have C bar T is equals to 0 indicates it is working as a timer. So crystal frequency divided by 12, it is working as a timer. So the down part is working for the external counter. So here C bar T is equals to 0 for the timer and C bar T1 T is equals to 1 is a counter which is only counting for TX pins which is occurring at port 3.4 and 3.5. Okay, and the last part is gate pin is equals to 1 which is going for the external hardware pins which are pin 3.2 and 3.4. INT 0 and INT pin will decide, and after that we will start the timer TR1 and then the counting goes on places. So this circuit is been divided into 3 parts. One is working for the timer, this part we have already seen, first part. Second one, when it is only working for the counter when C bar T bar is equals to 1, and the third part is working for the external inputs of gate pin, making gate is equals to 1 and taking the external inputs, hardware inputs of INT 0 and INT 1 which is given by the pin 3.2 and 3.32, which will make the counter to operate. And lastly we have the 8051C program which will toggle the port pins working at the timer 0 16-bit mode. 16-bit mode means 0000 to FFFF with some delay. So hash include void main, while for the toggling we have given previously 55, give some delay AA and the delay program. T mode is equals to 0 1 which is mode 1, that is 16-bit mode. TL is given with the initial value TL0 and TH0, that is given by 3500, and its delay, calculated delay is shown here, which is about 56.384 milliseconds approximately. Start the timer TR naught is equals to 1 because timer 0, while TF0 is equals to 0, TR when the timer flag rolls off, TR is equals to 0, TF is equals to 0. This is the simple C programming. And lastly, to increase the speed of 8051, we have seen that there are 12 clock pulses in one machine cycle. So increase the speed, they are reduce the clock pulses, which even they are reduced to 12 to 4 or even 1, which in turn increases speed of the microcontroller. And lastly, the frequency of the timer is always remains 1/12th of the frequency of the crystal attached to the 8051 regardless of any 8051 version.